Hello guys, once again, this is PV Tech Power Africa Solar, and today we are at Egerton University where we have installed 12 batteries of 200 Ah, and this system is going to be used to power a backup freezer at the biochemistry lab. So as you can see here, this system, we don't have panels powering this, charging the batteries. As you can see, we have connected the SPD, RCDs, the voltage regulator, which shows us as at now that the voltage of the supply to the university is quite high. We also have a DC, the breaker, an AC breaker, to ensure that whatever is fed to the inverter is within the right limit. As at now, we are not able to to see the AC power reflecting on the inverter. As you can see, the input power is 0 since the incoming power, which is Kenya Power, is above what the inverter needs. Ideally, our voltage is supposed to be it's supposed to be at the range of 240, but as you can see right now, this one is at 256, which is not healthy for our appliances. So as at now, the system is not able to charge the batteries until the issue is sorted out. But ideally, this system has no panels. It is only it's going to be used as a backup system, and ideally it's going to be charged by Kenya Power. So once the issue is sorted out, we'll have an input on the inverter. As you can see right now, we're having an output of 230. We have an output of 230. So once that is sorted out, we will be able to charge the batteries using Kenya Power. So we have the interface. So as you can see here, you're able to see the voltage bar. Voltage bar of the batteries. They're not fully charged because right now we don't have the charging option, which is Kenya Power. It's giving us an output of 230 volts. We also have an AC output breaker. This is just to protect whatever is being drawn from the inverter. We also have an automatic changeover here. So since we are going to be having the power from Kenya Power, it's going to be the primary source of supply here. Let me show you how. So if I turn the Kenya Power on, you can see, as you can see on the screen, we have normal power and standby power. So solar is going to be our, so as you can see from the changeover, we have normal power. So Kenya Power is going to be the normal power, and then the power from the inverter is going to be standby. So just in case there's a power blackout from the system, we'll be able to have a backup from the Kenya Power. So we also have an HRC fuse here, just in case there's more power being drawn from the system. We also have a bus bar. So in case you're interested in this kind of system, you can give us a call or contact us through our our social media pages, and we'll be able to help you. Thank you.